Good morning, everyone. Okay, sorry, we're back online, but better to be safe, I think. So any questions before I start? Okay, so today we are going to start section 8.5. Yesterday we did 8.3. I'm going to do 8.5 today, and then I will go back to 8.4, simply because 8.5 is actually more important. So I would like to do them in order of importance. So section 8.5. Partial fraction. So before I would like to ask you the following question. I'm going to give you two integrals, and I want to ask you which one is easy and which one is hard. So let me start by that. Suppose I give you the following integral. Okay, that's the first one. And this is my second one. Okay, and question is, which one is easy, which one is hard? Okay, the first one is easy. Anybody agree with Anna? Anyone agree? This is the easy one.
I am not
Okay,
sure.
why it is easy? Why this first one is easy and this one is not? Yes, I agree. Thanks, Cole. Why the first one is easy, Cole?
Because the derivative of the bottom is the top.
Absolutely. What we've always been talking about, the derivative of x squared minus 1 is basically 2x. So it's x up to a constant. So if I want to solve this, the first one, actually, I just set u to be x squared minus 4. The du is the 2x dx. And then this would become the integral of x dx. This will be half du. And this would be the 1 over u. So this would give me a half is a constant, antiderivative of 1 over u du, which is a half ln of u. It means, of course, plus a constant c, which is a half ln of x squared minus 4. Okay, so the first one is easy because substitution will do it. However, the second one is hard. Why it is hard? Because we cannot, there is no substitution in front of us. There is no, because the derivative of x squared minus 4 is not x, so there is no substitution inside. So that's really the hard one. Okay, and the goal of this section, one of the goals, which is this one will be done today, is how to find the antiderivative of something like that. All right, that's really what we are going to do. Now, before I move any further, there is a mistake that some of you do, and let's get that straight. We cannot split denominator. So there is tendency for some student that if I have something like 1 over x squared plus 4, some of you break it like that. They split the denominator. That's absolutely false. So we can't split denominator this way. Okay, we split numerator, but we can't split denominator. I mean, simply what I'm telling you is 1 plus 2 plus 3. This is not a half plus a third, right? Because common denominator tells me that this is going to be 5, 6. Right? So to get that straight, I don't want to see this mistake done anymore. Can't split denominator. It's the numerator. Means if I have x plus y over z, this is x over z plus y over z. numerator can be split and not the denominator. All right. Okay, so before we go and start attacking this type of problem, I will need a little bit of terminology. Let's do that. So some terminology. Basically, I want to define what we mean by rational function. But to be able to define it, I need the following. What do we mean in math by monomial? Okay, a monomial is nothing more than a function or an algebraic expression, is a function that has a very specific format.
That day, Friday, Saturday, Sunday.
Okay, I have to mute. Yeah, so a monomial is a function of the following form. P of x equal a certain constant a times x to the n, where n is a positive integer or n equal to 0. That's what n is allowed. A is a constant. Okay, so example of a, so n is a positive integer, and that's what matters to me. So example, right, monomial is one term. So for example, but not any one term, any one term. It's a term that have this following, the following. For example, if I take P of x equal 3 times x to the power 4, that's a monomial because it has exactly this form. N here is equal to 4, which is a positive integer. So that's a monomial. Okay. Now suppose I give you P of x equal I don't know, square root of x. Is this a monomial according to my definition? Yes or no, and why? Quickly. Yeah, it's no, it's not an integer. Absolutely correct, because this is x to the power a half. A half is not an integer. So the power here is a half, which is not an integer, a positive integer. So not monomial. So monomial are a very specific type of basically expression. I can keep giving you. What about 1 over x squared? Yes or no? Quickly. Yes or no? Yes?
No,
No, because.
x raised to the -2.
Right, that's x to the power -2. -2 is not a positive integer, and I insisted I want a positive integer. That's the definition. So again, no, not monomial. Okay, very good. Now, what's a polynomial? So that's monomial, as Alan said, mono stands for one. So it's one term, but it has a very specific format. Now, a polynomial is a sum of monomial. So it's a function which is adding those type of terms, polynomial. That's a sum of monomial. Okay, so example of a typical polynomial is 3x4 plus 2x cubed. Every term is a monomial. It means the power of x is a positive number. The power of x is positive, plus 3, for example. That's a typical polynomial. And the degree of a polynomial, the degree of the polynomial is the highest power of x that shows up. So the degree here is equal to 4. It's the highest power of x. That's the degree of the polynomial. Okay, so square root of x is not a polynomial. 1 over x squared is not a polynomial. That's really your typical polynomial. Finally, rational function. What's a rational function? A rational function is a function which is the ratio of two polynomials. So rational function. rational function is a function of the form f of x equal p of x over q of x, where p and q are polynomial, very specific type of function, are polynomial. That's a rational function. So, I mean, there are a lot of ratios. So if I give you f of x to be, let us say, sine x over cosine x, that's the ratio of two functions, but neither of them is a polynomial. So that's not a rational function. So rational functions are very, very specific type of function. The goal of this section, is to know how to integrate those type of function. Okay, so goal is how to find integral of p of x over q of x, where p and q polynomial. Basically, how to find the antiderivative of a rational function. That's really the goal of this function, or of this section. I'm going to start with a very, very basic example, simply because it comes up a lot. So very simple example, something that we know how to do. So basic example, Find the integral from 1 over, let's say, 2x minus 1 squared dx. Okay. Question number 1, is this a rational function? It means, when I mean this, I mean the integrand. So that's what we integrate is called an integrand. So when I say integral f of x dx, f is called integrand. Okay, so when I use the word integrand, that's really what I mean. So now my first question asks, is this a rational function? What's the is rational? It means it's the ratio of two polynomials. Yes, because the numerator is 1, that's the numerator, and the denominator, which is a polynomial, it's 2x minus 1 squared. Why it is polynomial? Because once you distribute here, you get 4x2 plus 1 minus 4x. It's a typical polynomial. Right? So that's the question is, let us find the antiderivative. And now I get back to you. How would you find the antiderivative of this expression? Quickly get going. Substitution, absolutely. There is no way out. The only way I can do it is substitution. Now, because, so what's the substitution? But I'm going to put u to be 2x minus 1. And the derivative of u is 2, which is not really a big deal. So u to be 2x minus 1. The du will be, derivative of 2x is a 2. 2 dx means a half du is dx. And now let us find this equal to. So this integral equal 1 over u squared times a half du. Half is a constant, I pull it out. Antiderivative of 1 over u squared du. 1 over u squared, the only way I can find its antiderivative is rewrite it as a u to the minus 2 du. And the rest is something we've done. It's a half. Antiderivative of u to the minus 2 is 1 over minus 2 plus 1. Minus 2 plus 1 is minus 1. So this will give me minus 1 over u plus c, which is finally give me minus 1 over 2x minus 1 plus c. Okay, so that's a very basic rational function, and integrating it is actually not hard. It's just a simple substitution. Okay, so we did 2 so far, rational function. We did This one, that's the rational function. Numerator is x, denominator x squared minus 4. We were able to do it by substitution. And that's another one where we were able to do it by substitution. Now we will consider the following problem. Okay. So let us consider the following. Let's consider this. Okay. Now find integral of, let us say 3 over x squared minus x minus 2 dx. Okay, want to find the antiderivative. Okay, that's hard because if I look at it, no substitution inside. It means if I set u to be the denominator, x squared minus x, the du is 2x minus 1. Definitely, I don't have it. So that here, substitution absolutely fails. Well, there is no way I can do it. So how are we going to find the antiderivative? All right, let us say that I take this expression, we don't have, okay, and I tell you that by magic for now, that this is the same thing as 1 over x minus 2 minus 1 over x plus 1. Okay. What does it mean that this is equal to that? What does it mean? I tell you, okay, this expression, let us say I tell you, okay, this expression is the same as this expression. What does it mean that those are the same? It means the following. If I take the expression on the right, find the common denominator, I should get exactly that. So that's what it means, those two are the same. So I'll show you. So because you have to understand what does this equality mean? It means that if I take the expression to the right and I find a common denominator, which is the product, this will be x minus 2 times x plus 1 minus x minus 2. So if I find a common denominator, let's see what I get. X plus 1 minus x plus 3. Plus 2. And here, if I distribute, I will get x squared plus x minus 2x minus 2. So this would give me 3 over x squared minus x minus 2. Okay, so what I'm saying here, could it be 3 times x minus 2? I don't understand your question, Alan.
I mean, if you're splitting up the fraction, couldn't you just like put the 3 in the denominator and then that would set it to equal? Or am I just thinking it differently?
No. I mean, I'm splitting it. Those have to be equal. The 3 is in the numerator. Why am I going to bring it down? I don't change the expression.
Okay.
Okay, I'm changing. So what does it mean to be equal? So it means that basically what I'm telling you, when I set equal, what I'm really telling you, I'm telling you that those are exactly the same thing. Because if I take the right, find a common denominator, I'm going to get the left. That's what equal means. It means those are the same. But what's the benefit of being able to, what we're going to call decompose? And that's what the goal is, to learn how to do that. What's the goal of this? If I write this expression this way, what's the benefit? The benefit is going to be that the integral of the expression to the right, to the left, will be equal to the antiderivative of this one. So usually, as you realize, always we try to do something to the expression so we can rewrite it in an easier format. Now, the one to the right is this minus that. Now, is this integral easy or hard? Quickly.
Easy.
Easy. It's going to give you ln. Easy or hard? Easy. Plus c, end of the problem. Okay, so if I can decompose my function somehow into simpler function, then integrating it will be easy. So now the big question is how to do that. And that will be the content of this whole chapter, how to decompose a function into a simpler function that we can integrate much easier. This idea of decomposing a function into simpler will be called partial fraction decomposition. And the question is how to do it. All right. So decomposing a function into simpler function is called a rational function. Into simpler. Simpler, I mean something we can integrate into simpler rational function. Is called partial fraction decomposition. Partial fraction decomposition. And the question is how to do it. So the big question is how to do it. Because if I can do it, solving will be easy. Okay. All right. The problem is going to have a lot of cases and sub-cases. So I apologize for that ahead of time, but that's really the only situation. Right, so we start with a rational function. So our big case first, we're going to start with a rational function. P of x over Q of x, where? So what I'm going to be doing is going to be correct mathematically under the following condition, where the degree of the numerator is strictly less than the degree of the denominator. So we're going to develop a technique today and tomorrow and the day after, but it works as long as the degree here, that's a polynomial, is less than the degree of the denominator. Okay. The first step in the composition is to factor out, so the first step in the composition is to factor out the denominator completely. Factor out, that's the first crucial step, the denominator completely. Completely. Okay, so whenever you have a rational function, if substitution fail, you have to do something that we're going to learn today. The first step is total factorization of the denominator. And then our technique that we're going to develop will depend on the factors that will show up in the denominator. So my case one, so the discussion will depend, so the discussion depends on the factor of the polynomial, of the denominator. Okay. So we're taking particular rational function where the degree of p is less than the degree of numerator less than the degree. The first step we will be doing is factor out the denominator completely. And now, once we factor it out, what shall we proceed? The way we proceed is going to depend on what type of factor we have the denominator. So today we're going to start with the first type. So case one or subcase one, the denominator, let me call it Q of x, okay, is a product. That's the first big case, is a product of distinct means different, linear factor. Of course, I have to explain every word. Distinct, it means different. What's a linear factor? Linear factor is a factor of the form ax plus b, where a, of course, is different from 0. So that's a linear factor, means a factor that has the form ax plus b. All right. So let us start. So suppose I have a function. Let me take 3 over x squared minus x minus 2, the one I just gave you, which is this one. Okay. And how do we decompose? So step 1, factor out the denominator completely. I'm going to factor out the denominator completely. Okay, the factors are a 2 and a 1, x and x, minus x plus 1. So step number 1, not the most important, we have to factor out. Once you factor out, I check if I did the factorization correct. X squared plus x minus 2x minus x minus 2. Now, what math tells you? Math tells you the following. There is a big theorem in math that tells you that if you have an expression of this form, so a numerator with the degree of the numerator less than the degree of the denominator, and if you factor out the denominator completely and you get this type of factor, mathematically, we can show that this could be written in the following format. A constant a over x minus 2, that's what math tells us, that this is possible, plus a constant b over x plus 2. So mathematically, they tell us that this, we should be able to write it as a constant a over x minus 2 being the first factor, plus a constant b over x plus 1, which is the second factor. Our job would be to find the a and b. So math tells me this is correct mathematically. My job is to find a and b. Okay, so our job is how to find the a and b. And that's the easy part, actually. Okay, math tells me you can do it. My job is to find the n. So let's see how we're going to find n. We're going to find them as the following. We say that math tells me that those are equal. If those are equal, or this is something that we can do, I'm going to multiply this expression across by this common denominator, x minus 2 times x plus 1. So now how to find a and b? Multiply across by the common denominator. The common denominator, which is x minus 2 times x plus 1. Okay, so what I'm saying that I'm going to take this piece right here and I'm going to multiply across by that. Since math tells me those are equal, then fine, I can multiply and they are still equal. That's what a theorem in math tells you. It tells you that you can write this expression as a constant over x minus 2 plus another constant over x plus 1. This is mathematically correct. Your job is to be able to find them. Okay, so that's what math tells you. There's a theorem that tells you this could be done. Your job is to find them. All right, I'm going to multiply across by this. So let us do that. I'm going to multiply this by x minus 2 times x plus 1. I'm going to multiply this x minus 2 times x. I have to multiply across and see what I get. Okay, let's see what I do. If I multiply this term by x minus 2 times x plus 1, I will get a 3. And definitely we're multiplying, so we get rid of the denominator, so I don't have to deal with it. Now, this expression, if I multiply it by x minus 2 and x plus 1, x minus 2 and x minus 2 will cancel each other out, and I will have a times x plus 1 plus b. Again, I'm multiplying by x minus 2 times x plus 1, So I multiply by the same thing across, the x plus 1 simplify, and this is I will have x minus 2. Right? So math tells me you can do that. Now my job is to be able to find the a and b. And math tells me that those are equal no matter what x is. All right. So when I multiply, I say, okay, those two expressions should be equal no matter what x is. I mean, whichever the value of x I plug in here, I should be able to get 3. All right, and this is mathematically justified. So the question is how I'm going to use that to solve for a and b. Okay. I say, all right, since those are equal, should be equal, no matter what the value of x is, means that if I plug in, let's say x equal 2 in this, the right, and I plug in x equal 2 in the left, I should get the exact same answer. So I'm going to say, okay, I'm going to plug in. My goal is to find a and b. And then in a minute, you understand why I took x equal to 2. I say, okay, I'm going to plug in. We're going to set x equal to in both parts. And I'm going to use this to find the a. So if I put x equal 2 here, there is no x, it's going to stay a3. And if I put x equal 2 here, I will get 2 plus 1. And if I pick x equal 2 here, I will have a 0. And I'm going to use this trick to be able to find my a. So this would give me that my a equal 2 plus 1 is a 3, 3a. Sorry. That's going to give me 3 equal 3a plus 0. And then this will tell me that my a should be equal to 1. Okay, so my idea that once I reach this stage, I said those two expressions have to be the same regardless what x is. So I'm going to pick specific values of x, very specific value of x, which help me to find a and b. Now, of course, if I pick x equal to 2, this piece would make this expression 0, then I can pull out the a. That's the logic we're using. Now, if I want to pull out, so I have a. Now I want to find b. Which value of x I should substitute in both expressions to be able to find the b. Okay. So I look very carefully. I want the b. So let me see if I can somehow get rid of the a. I look here, I said, you know, if I take x to be minus 1, I plug it back into this will give me a 0, and this will allow me to find the b. That's the logic we are going to use. So I plug in x equal minus 1 in this expression. I get 3 equal a times minus 1 plus 1 plus b times minus 1 minus 2. And this would give me 3 equal minus 1 plus 1 is 0 minus 3b. And now I solve for b, I get b equal to minus 1. Okay. So step number 1. I decompose the way I will tell you how to decompose each time. And this is where a math theorem tells us that we can do it. Once we do this decomposition, my goal is to find a and b. We multiply the whole thing across by the common denominator. It means basically we have to multiply by x minus 2 times x plus 1. Once we do that, we don't have denominator in the picture. I said, okay, those have to be equal regardless what x I plug in. So I'm going to plug in specific values of x, which are usually the zeros of the denominator. It means x equal 2, x equal minus 1. Those are the value I'll plug in. So I'm going to plug in specific value of x to be pull out the a and b, based on the idea that those have to be equal regardless what x I have. So I plug in x equal to 2. I pull a. Then I plug in x equal minus 1. I pull the b. So what does this tell me here? This tells me that. So the math we did tells me the following. That my expression, this one right here, 3 over x squared minus x minus 2 is equal to a. My a is 1 over x minus 2 plus b. My b is minus 1 over x plus 1. That's how the constant are found. Now, if you want to check your work, you start from the right, common denominator, you should get the left. If you don't, it means this equality doesn't make sense or whatsoever. Once I decompose my expression into simpler one, it's easy. I just integrate both sides. So now we go back to the integration. So now I will get the antiderivative of 3 over x squared minus x minus 2 dx equal to antiderivative of 1 over x minus 2 dx minus 1 over x plus 1 dx. Okay. Now I have simpler one, definitely simple. I evaluate each one of them. Okay, so let me evaluate this. I will do it today. I evaluate them. So now let me do each one of them. 1 over x minus 2 dx. To evaluate this, I put u to be x minus 2. The du will be dx. And then this would become 1 over u du. ln of u. It means ln of x minus 2. Let's take care of the first. The second, I will do it in a very similar fashion. 1 over x plus 1 dx. U is x plus 1. Du is dx. Here I am lucky that the du is the same thing as dx. We don't have to have that. ln of u, ln of x plus 1. And so finally, my antiderivative is ln of x minus 2 plus the ln of x plus 1 and of the problem. Okay, so we're going to do another one along the same line. And then if we have time, we'll move to another scenario. Question before I go on. Problem number 2. This accord the same ideas I'm going to follow. So my example is find this integral of 3x plus 2 over x cubed minus 3x squared plus 2x dx. Okay. Of course, if you look at it, it's outrageous. How I'm going to find the antiderivative of this function? And first, I ask myself, is substitution going to work? So it means that if I put u to be my denominator, u to be the denominator, its derivative is 3x squared minus 6x plus 2, nowhere to show up. So substitution will be absolutely out of question. So the only way to do it is we're going to use what we call partial fraction decomposition. Now, first, let us know that this is a rational function. That's absolutely a polynomial over a polynomial. Numerator 3x plus 2, denominator is x2. Second, we're going to see that the degree of the denominator, because everything I'm telling you is now work only when degree of the numerator is less. So degree of the numerator, which is 1, is less than the degree of the denominator. But the technique I'm telling you about only work in this situation. Now, what's the first step in the process? What's the first step? Anybody remember?
Decompose.
What? Before. Before we decompose, what should we do?
You factor out the denominator.
Exactly. Step number 1, before common denominator, factor out the denominator completely. All right, so factor out the denominator completely. Let us factor out the denominator. So it's x cubed minus 3x squared plus 2x. How are you going to factor it out? What would you do? Quickly. Factor it out. Have you right to product of terms? Totally. First, I will factor out the x. And I will have x squared, yes, minus 3x plus 2. When I mean completely, I mean completely. This is not totally factored. This is, we still have an x squared. So I have to keep pushing till I can't do it anymore. X, now x here, and should be a 2, x and should be a 1. And then since I have a minus here, that's factorization. Step number 1, totally factor into linear. Step number 2, what type of factor I have? This is a linear factor. This is linear because the power here is 1, and this is linear because the power is 1. And they are distinct. No two are the same. Because if two are the same, we will see that the decomposition is going to change. So I am in the same situation that in the previous problem. In this case, the factorization will go like that. So I'm going to rewrite this here. The factorization, this is where math tells me you can do. Math tells me that you can write this as a certain constant a over x, that's the first factor, plus a certain constant b over x minus 2, that's the second factor, plus a certain constant c over x minus 1. That's what math tells me you can do that. A and b and c are constant. And now the question is, we need to find them. How to find them? I repeat the same process before. We multiply across by this common denominator. Basically, I want to get rid of that by x times x minus 2, x minus 1. And let's see what we get. So I have to multiply this by x times x minus 2, x minus 1. Everything across the board. Multiply. Again. Okay. And then let's see what we have. So if we do this, the first one will give me 3x plus 2 equal a, x and x cancel each other out. It would leave me with x minus 2, x minus 1 plus b, x minus 2 gets simplified. I will be left with x times x minus 1. And finally, x minus 1 gets simplified. I will be left with x times x minus 2. And now I want to find the a and the b and the c. Usually there are two ways of finding a, b, and c. Now, today and tomorrow, I'll emphasize one way, and on Monday, I will show you in other ways. Okay, so how we're going to find a, b, and c? We're going to use the same idea that I used a minute ago. I said, those expressions should be the same regardless what x is. So I'm going to pick particular values of x and substitute in both expressions to be able to find the a and the b and the c. And now what do you think the values I'm going to use to find a, b, and c? Let's see if you guys built any intuition. I think you did. Okay, anyone think which value of x will help us? Two, 1, and 0, exactly. What we're going to pick is actually the zeros of those, 0, 2, and 1. That's usually the idea. And why is that? Because let's see, if I put x equal to 2, this will make those two expressions zeros. I will pull out the b. That's really how it works. So x equal to 2, but be careful, we're going to put 2 in both expressions, here and here, not in one without the others. So I'm going to put my 2 in here. I will get 3. So I will be slow. First times 2 plus 2. So I have to put 2 across the board, equal. A times, I'm going to have a 0 plus b times 2 minus 1 plus c If I plug in a 2 in here, times is 0. And this should save me, and this would give me 3 times 6 plus 2 would give me an 8 equal to B, which give me B equal to 4. So at this stage, the process is actually simple. Then I will plug in x equal to 1. And this would give me 3 times 1. So I plug in 1 in here, equal. I plug in 1, I will get A times 0, plus. I plug in 1, I get B times 0, plus. I plug in 1, I get C times 1 times 1 minus 2. This would give me 3 plus 2, it's a 5, equal to C. I'm done with C. So finally, I will have x equal 0. I plug in 3 in here. 3 times 0 plus 2 equal A times, so there is no zeros now, 0 minus 2 times 0 minus 1 plus, plug in is 0 here, plug in is 0 here. Finally, I will get 2 equal to A, means A equal to 1. Right? So now let us put the whole thing together. So it's actually, as I told you, it is simple. It is actually simple at this stage. But getting there required a lot of mathematics. All right, so now I put the whole thing together. So now this tells me that my original complicated nightmare expression, which is this one, can be decomposed into A. My A is 1. B. My B is 4. C. My C is 5. Over, and the term for C is x minus. Okay. So this expression is equal to that. Now, I'll ask you again, if you are in doubt, how can you make sure that you get the right decomposition? How can you make sure that you're doing the math correct, that this equality is a correct equality? Because equal means the same for all x. How do you convince yourself?
Find a common denominator between all of them and then multiply it out.
Common denominator where? Which side? Multiply the denominator if
The
you,
right side.
the right side. We take the right side, find common denominator, do the math, you should get the left side. If you don't do that, it means you're not doing the right thing. Is that clear? That's what it means. Those are the same, like 2 equal 2. That's what this means, okay? No matter what x is. Now we integrate. Now we're back to the antiderivative. So as you realize, the antiderivative at this stage is not hard anymore. It was a nightmare at the beginning. It's going to be the antiderivative of 1 over x plus 4 over x minus 2 dx plus 5 over x minus 1 dx equal to antiderivative of 1 over x is the ln of x plus this 4 is a constant. I pull it out and then I deal with this. 5 is a constant, pull it out, then I deal with that. Equal to ln of x plus 4 times. Now from here to here, I do the substitution u equal x minus 2. Now the du will be exactly dx. So this tells me that this expression is going to be the ln of x minus 2 plus 5. For the same reason, if I put u x minus 1, du is dx. So this will give me ln of absolute value of x minus 1 plus a constant c and of the problem. All right. So that's it for today. We took one scenario. Tomorrow we're going to take a different scenario. When I mean different scenario, it means what other factors can come up in the denominator. So they don't have to be like linear and distinct. So what if the denominator is x minus 1 squared times x plus 2? So the factors, some of them repeat. And the question is, what's the decomposition that is work for those problems? Okay. If c minus 5, I don't really know.
Isn't that just the constant?
Oh, yeah. C is minus 5. Yeah.
Professor?
Give me a second. Yes, what's up?
Yeah, that's a negative.
Thank you very much. Thank you very much. Any other questions? All right, so for tomorrow, you have to give me 15 minutes to put the homework on Brightspace. Somehow I forgot last night. And for your quiz tomorrow, this will definitely be on the quiz. I think this is easy. Do your homework. And then you will have all about trigonometric integral on your quiz. Everything involving sine, cosine, integrals that involve tangent and secant. All right, so make sure you memorize those identities. You remember those I will not give you tomorrow. It means I want you to know derivative of secant. I want you to know derivative of tangent. Of course, sine and cosine, all of you know it. And then I want you to know the following formula. Remember the relationship. You should never forget the relationship between sine and cosine. And this will allow you to write cosine in terms of sine and sine in terms of cosine. This you have to have it under your belt, no question asked. The other formula I expect you to know for tomorrow is the relationship between secant and tangent, because this is another one of those that you need to know. Secant square is the same as 1 plus tangent square, which gives you tangent square. Once you know this, you know that is secant square minus 1. So you memorize this, this will fall immediately. The double angle formula, the half angle formula, I will give it to you. So that's the only formula I will give you tomorrow is the half angle, which is this one. This I will give you. It's not sure memorize it, but I will give you that. I will not give you those because those you have to learn. Okay. Any questions? No, the class is up. Any questions about anything?